Good morning, students. How are you all? Hope that you all will be fine with the grace of the God. Students, today I am going to start with the application of the integrals, that is your chapter number 8. So, in this chapter, students, we are going to discuss the area under the simple curves and area between the line and the circle, ellipse and parabola. Already students, in the plus 1 class you have done the chapter conic section. So here once again we are making the use of parabola, ellipse and circle here. So let us, before starting the exercise questions, I want to tell you some basic points that we are going to discuss in this chapter. So students, first of all let us come with circle. In circle, students, if we having a circle like this, the center of the circle we are taking here h and k. This is the center of the circle, this is the radius. So actually we have to discuss the equation of the circle. So if the equation of the circle will come as x minus h square plus y minus k square, this is equal to r square. So here in this chapter we will make the use of the circle, and after that there is parabola. There is parabolas. We having four types of the parabola, students. First one is, that is y square is equal to 4ax. Try to understand here, while we will discuss the application of the integrals, we will find out the area of the parabolas. So you must have the knowledge, when y square is equal to 4x, then there is this type of the parabola is there, students. That is, the parabola is toward x-axis. This is x, this is x dash, this is y, y dash. This is the parabola. Here this is the focus. So y square is equal to 4x. The parabola is toward x-axis. Then second parabola is there, students. That is y square is equal to minus 4ax. The parabola is like this. Third one is, that is x square is equal to 4ay. Now the parabola is like this. And last one is, students, that is, this is x, this is x dash, this is y dash. Now here the parabola is x square is equal to minus 4ay, and the parabola is like this. Here, students, you have to understand the shape of the parabolas, and because there will be the question that we have to find out the area of the parabola of the shaded region. Maybe the shaded region will lie here. So here, if I want to tell you, for example, if I am taking this, that is x, I have drawn a line that is x as equal to 4, then we have to find out the area of this shaded region. For that, it must be clear to you what are the equations of the parabolas in the different four cases. Right, students? After that, we will discuss. I am not going in very depth. I am not going to tell you once again focus, their vertices. You all know it. But here I want to tell you how to draw these parabolas. Second one is there, students, that is ellipse. Its general form is x square upon a square plus y square upon b square, that is equal to 1. Now students, here this ellipse that I have taken, this is x dash, this is y dash, this is origin. The ellipse that I have taken toward x-axis. Second one is, here we having two types of the ellipse there, toward x-axis and toward y-axis. This is y dash. x dash, and this is x, this is origin, this is here, then students like this. The standard form will here like this. When the ellipse is toward x-axis, students, from here we have to check if a square is greater than b square, or we can say that if a is greater than b, then we can say that this ellipse is toward x-axis. In the second case, equation is same, x square upon a square plus y square upon b square, that is equal to 1. But here, student, a square is less than b square, or a is less than b. If a is less than b, then we can say that this ellipse will lie toward y-axis. So these are the two different ellipse we have, students. So here we will make the use, in this chapter we will make the use of the ellipse also to discuss the area of the ellipse. Maybe the line will pass, maybe the ellipse, for example, the question may be like this: the ellipse is toward x-axis. If the ellipse is toward the x-axis, we have to find out this area then, students. So that is why you must have the knowledge about these ellipse then, students. Now students, here we are going to discuss area under simple curve. This is very important. Before doing the exercise question, we have given one of the, this is y is equal to fx. This is a curve. This is a bonded curve, that is y is equal to fx. I have taken this curve. This is bonded between the line x is equal to a and y is equal to b. Now students, we have to find out the area of this bonded curve. For that, what we will do, we think that the area under the curve are composed of large number of very thin vertical strips. We will divide this bonded area into these strips. These are the strips, 1, 2, like that. And the maximum height of the strip is y, and this is the height. This is, we can say, length. This is breadth, because this is in the form of a rectangle. So we will find out its area, that is, its area is length into breadth, y into dx. So students, area, that is equal to, it is bonded between x to a. So lower limit is equal to a, the upper limit, that is equal to b, d of a, that is y of dx. Y, length into breadth, y into dx, that is a to b, y of dx. We will put the value of y here, and very simply we can find out the area of the bonded region. Now here, students, now this is toward x-axis. Now I have taken this toward y-axis. Again I have taken a bonded curve, x is equal to gy, and the lines are y is equal to c and y is equal to d. We having two lines. Between these two lines, this curve is bonded. Now students, once again, if we have to find out the area of this bonded region, again this strip I have shown here, where length and breadth x and dy we have taken. So while we have to find out its area will come as equal to lower limit, that is equal to integration lower limit c to d x into dy. We will put the value of x here, and using the integration, we will make the use of integration that already you have done. We can find out the area of this bonded region then, students. So this is very important to understand, students, that a is equal to y dx from a to b, a is equal to c to d x dy. It's depend upon you in the question that toward x-axis you want to solve the question, or toward y-axis you want to solve the question. With the help of these, that is area under the simple curve, with the help of that one, you can do the exercise question, students. So we will make the use of these basic concepts, students, while we will do the exercise questions. And I want that whatever the formula that you have done in the integral chapter, you revise it first before doing this chapter, because we will make the use of those formula also here in this chapter. So one more thing that I want to tell you, that while you will draw these graph, so it will be good for you, for your better understanding, if you will draw the graph on the graph paper and you shade the region on the graph paper, very clearly you can indicate the area, which one area is bonded area there. So make use of the graph pages while you have to indicate the shaded region, then students.